We are now ready to start loading our graphs. Thankfully for us, it is quite simpler than saving. To make it easier for us though, we'll be iterating through what we are going to do. The first thing we'll be needing is to load our graph scriptable object into the respective data variable. With that variable, we'll be able to access all the data we need to start loading our elements. Right after we load our variable, we'll start by updating the graph file name to be the name of the loaded graph. That's because if we are loading the graph, it is likely that we want to update it. So when we are done doing that, we can simply press in save without needing to manually update the name. When that's done, we'll need to load our groups and our nodes. We can load them in whatever order we desire, so either our groups first and then our nodes, or our nodes first and then our groups. The code will only be slightly different. In the first one, we will add the groups to a dictionary, and when we start iterating through our nodes, we will get the group the node belongs to through that dictionary. I'll set its group variable to that group and add it as an element to the group, so that our node becomes a grouped node. In the second one, we will add the nodes to a dictionary that the key was the group the node belongs to or its ID, and the value was a list of nodes that belong to that group. With that, when iterating through our groups, we will simply get a dictionary element that has the key of the current group and get its value, to which we will then need to iterate through the nodes and set their group variable and add them as elements to the group as well, for them to become grouped nodes. You are free to go with whichever you prefer, but I'll follow the same order as in our saving system. Groups first and nodes second. With them loaded, we'll have to set our LoadNodeChoices connections, making sure we connect them with an edge as well. That's basically how we are going to load our graphs. So to do that, start by going into our DSIO utility script. In here, under our save methods region, we'll create our load method by typing in public static void load. I'll make it part of a new region named load methods. In here, let's start by loading our graph data scriptable object. We don't really have a method for loading, but we know that in our CreateAsset method we first try to load our asset, so we could possibly use that. However, the problem with using that method is that if it doesn't load, it will create a new asset. This is a problem because we are trying to load a certain graph and not to save one, so there is no reason for us to create a new asset. To fix that problem, we'll simply grab the part of our CreateAsset method that loads the asset and make it a new method. So in our CreateAsset method, select our LoadAsset at path code, and if you are using Visual Studio, press Alt-Enter and select Extract Method. I'll name the method LoadAsset. I'll be separating the parameter into two different parameters, so rename the current parameter to path and create a new one of type string, to which I'll name AssetName. Then, copy the CreateAsset full path variable and paste it in our LoadAsset method. Make sure you swap the full path with path and asset name in our LoadAsset method call as well. With that done, back to our load method, we can load our desired graph asset. To do that, type in dsgraph savedata.so, to which I'll name graph data and assign LoadAsset of type dsgraph savedata.so, and I'll pass in the path of assets, @editor, @dialog system, @graphs without a slash at the end, and the asset name of graph filename. This graph filename will already contain the graph at the end of the name whenever we call our load method, so we don't need to add it here. We are now loading our graph, but to make sure no error happens, we'll throw in a dialog error in case the asset we've tried to load in is null. To do that, type in if graphData == null, and inside type in editor utility .display dialog. For the title, I'll pass in couldn't load the file. For the message, we'll be having multiple lines, so we could either use the operator, which will make it so the string is read literally, ignoring escape characters, or simply use the \n to add an enter and the plus operator to divide it into multiple lines. I'll go with the second one simply because I'll also make the string code be in multiple lines for better organization using the plus sign to concatenate them. With the at operator, tabs will also be read literally. So type in the file at the following path could not be found, and I'll give it 2 enters. Then make sure you concatenate a string by typing in plus after the string, and in a new line start the author with an interpolated string saying assets at editor at dialog system at graphs at graph filename, ending with 2 enters as well. Concatenate another string and type in make sure you choose the right file and it's placed at the folder path mentioned above. For our OK message, we'll simply pass in thanks. This is what it will look like with the at operator. At the end, simply return so that the graph doesn't get loaded. Next, we'll be updating our toolbar filename. To do that, simply type in ds-editor window.update filename and pass in graphdata.filename. We can do this because our update filename method is static. We will not pass in graph filename here because it also contains a graph string at the end of the name, which we don't want in our graph filename text field. If you don't remember, we have set our graphdata filename variable through its Initialize method. We can now start loading our elements. Of course, we'll load our groups first, so call in a new method we'll create named LoadGroups, and pass in graphdata.groups as an argument. In here, we'll iterate through the groups by typing in for each dsGroup save data group data in groups. Inside this loop, for each group, we'll simply have to create it using our GraphView createGroup method. So create a new variable of type dsGroup, which I'll name group, and assign to it GraphView.createGroup, passing in groupData.name as the first argument, and groupData.position as the second. With this done, our group is in the GraphView already because we have our add element in the createGroup method. So the only thing left to do is to set the rest of its variables to all the group data values. We only have our ID for our group, so type in group.id equals to groupdata.id. We already know we are going to need a reference to the group each node belongs to be able to set their group variable and add them as elements to the group. So we'll create a dictionary that also loaded groups now. To do that, in our variables above, create a new private static dictionary with string as the key type, which will be our group ID, and dsGroup as the value, which will be our actual group. We need the ID as a key because in our data class we have saved the group ID. I'll name it loadedGroups. Then initialize this dictionary in our Initialize method. Back to our loadGroups method, we then add the current group to the dictionary by typing in loadedGroups.add group.id as the key and group as the value. We are now done loading our groups, so we'll need to do the same for our nodes. So in our load method, just under the loadGroups method, call in a new method we'll create named loadNodes. Pass in graphdata.nodes as an argument. I'll place it under our loadGroups method. Start by iterating through the nodes data by typing in for each dsNode save data node data in nodes. We'll then create our dsNode variable, which I'll name node, and assign GraphView.createNode to it. As arguments, pass in nodeData.dialogType and nodeData.position. This one will be a bit different though, because before we add our node, we want to draw the node. However, right now the draw method is always being called in our CreateNode method. This is a problem because by then our data isn't yet updated, as we haven't yet set the node variables to hold the correct loaded data. We'll also have the problem of not having our name updated in time before we add our node as an ungrouped node. We'll be fixing these problems by adding a new parameter to the CreateNode method that tells us whether we should draw the node or not, and adding another for our node name in which we'll then pass in to the Initialize method. So in our CreateNode method, pass in a new parameter in beginning of type string to which I'll name nodename. Then pass in a new parameter at the end of type bool to which I'll name shouldDraw and default its value to true. Pass the nodename to the Initialize method, and in there we need to make sure we add in a new string parameter to which I'll name nodename, and assign this parameter to the dialog name variable. Make sure you also update the single choice and multiple choice node scripts to have this variable in their Initialize method. Then, back to our CreateNode method, we'll add the node.draw method inside of an if statement that checks if shouldDraw. Do make sure you update every CreateNode method call to pass in dialog name as the node name. You could just default the node name to this name if you wanted to, but you will need to add it as one of the last parameters. Feel free to do it as you desire. Back to our DSIA utility LoadNodes method, pass in nodeData.name as the first argument and then false as the last argument, meaning our node won't be drawn anymore. With that done, we shall now update our node data. So type in node.id equals to nodeData.id. Then node.choices equals to nodeData.choices. And node.text equals to nodeData.text. When that's done, we can then call in node.draw, which will then draw the node with the correct data. If we haven't added the showDraw variable, every UI element would have been drawn twice, in which the first one would have the old data. When that's done, we need to make sure it is added to our GraphView by typing in GraphView.addElement and pass in node. We have done this before adding our node into a group because if the node wasn't part of the GraphView, then the corresponding callbacks won't be called. And we also don't really need to know anything about the group to be able to draw the node. Now that we can do that, we'll need to add a group to our node if it is part of one. So type in if string.isNull or empty and pass in nodeData.groupId. If that's the case, we don't need to add it to any group, so we can simply continue. Otherwise, we'll create a new variable of type tsGroup, which I'll name group, and get it through the loadedGroups dictionary. So loadedGroups at the key of nodeData.groupId. We can now set the group by typing in node.group equals to group. To make it a grouped node, we need to type in group.addElement and pass in node. We are almost done loading our nodes, but you might have noticed we have set the node choices to be equal to the node data choices. If you remember from our saving system, this is a problem because the node choices are now a reference to the node data choices, as it is a list. This simply means we'll update the scriptable object choices whenever we update them in our graph. So we'll simply have to clone them much like we did in our save method. That also means we don't really need to do it again and can just make it a method that we can reuse here. So go to our save node to graph method, and when you get there, select the code where we clone the choices list up until the list initialization, and if you are in Visual Studio, press Alt Enter and choose Extract Method. I'll name it CloneNodeChoices. I actually want the parameter to be the list of node choices, so I'll set its type to be list of tsChoice saved data and rename it to be node choices through the F2 key. Of course, remove the .choices from the forEach method. Back where we call it, make sure you now pass in node.choices instead of node. I'll also make it part of the utility methods region. Back in our loadNodes method, create a new list above our node of type tsChoice saved data, which I'll name choices. Then assign to the list CloneNodeChoices and pass in nodeData.choices. When that's done, swap our nodeData.choices on the data update with choices instead. We are now loading both our groups and our nodes. All that's left loading are our node connections. So in our load method, just under our LoadNodes method, call in a new method we'll be creating named LoadNodesConnections. I'll place it under our LoadNodes method. Of course, we want to iterate through every node that we have created and update their connections. However, we don't really have a way to iterate through our created or loaded nodes. So of course, much like we did a dictionary for our loadedGroups, we'll create one for our nodes. So in our variables above, create a new private static dictionary with a key type of string for the node ID and value type of tsNode. I'll name it loadedNodes. When that's done, initialize it in our Initialize method. Then, in our loadedNodes method, right after we add it to the GraphView, type in loadedNodes.add and pass in node.id as the key and node as the value. Back to our LoadNodesConnections method, we can now iterate through the loadedNodes by typing in for each key value pair with string as a key type and tsNode as value type, loadedNode in loadedNodes. In here, we'll be iterating through each node port, and if its choice data contains something in the node ID variable, we'll get the node with that ID and connect its input port with the current port, which creates an edge. So inside, type in for each port choice port in loadedNode.value, which gets the node.outputContainer.children. Make sure you import the port namespace. We can use port right away here because we know in our case that the output container only contains ports as its children. Then we need to somehow get the choice data. Thankfully for us, when we draw our nodes, we iterate through its choices and create the ports. And when we create them, we also set their user data variable to contain the choice data. This means that we can simply cast that user data to our choice data type and use it. So type in tsChoice saved data, to which I'll name choice data equals to choiceport.userData, and then cast it. If this choice data node ID variable is null, we don't want to connect it. So type in if string.isNull or empty choiceData.nodeID. And if that's the case, simply continue to the next element. If there is an ID, we need to get the connected or next node to be able to get its input port and then connect it to the current port, which is the current node choice output port. To do that, create a new variable of type tsNode, which I'll name nextNode, and assign to it loadedNodes at the key of choiceData.nodeID. To get our input port, we type in port nextNode input port equals to nextNode.inputContainer.children.first and cast it to port. We can use the link namespace first method here because in our system our input container only has one element, which is the input port. We can now connect the ports by typing in choiceport.connectTo and pass in next node input port. Our ports are now connected. However, this method doesn't really add an edge to the graph. Thankfully though, it does return an edge from the method, so we can simply get it and add it to the graph ourselves. So assign this connection to a new variable of type edge, to which I'll name edge. Then add it to the GraphView by typing in GraphView.addElement and pass in edge. We are now loading our connections. There is one last thing we need to do though, and that's calling in the node refreshPorts method, as we have just updated this node port, so we need to make sure we refresh it. So at the end of the loop, type in loadedNode.value.refreshPorts. With that done, our loading system is also done. The only thing left to do is to add a load button to our toolbar. So in our DS editor window script, in our add toolbar method, create a new button to which I'll name loadButton. Then assign DSElementUtility.createButton and pass in load as a text. As our callback, we'll be calling in a new method we'll create named load. I'll make it part of the toolbar actions region and place it under the save method. In here, we'll have to do a few things to load our graph. The first thing we need to do is to choose the graph asset we want to load. Thankfully, Unity provides us with the editor utility openFilePanel method, which basically opens our operative system window and allows us to choose a file. So type in editorUtility.openFilePanel. In here, we have three parameters. The first one is title, which is the text that will show up on top of our window. I'll pass in Dialog Graphs. The second one is the directory. This simply means what's the directory that the user will be in when the window opens. The user can still change directories as they want. Sending in an empty string opens it up at the assets directory. I'll pass in assets, at editor, at dialog system, at graphs. If this path does not exist yet, it will go to another. For example, mine goes to the Windows Documents folder. The third one is the extension, which is just what type of files you want to be able to load. You will be able to swap between this file type and all files. I'll pass in asset, as that's the type assets use. You do not need to type in a dot. This method returns the whole path of the file you have selected, which we will need. So assign the returned value to a new string that I'll name filePath. Then we only want to load the graph if the file path is not empty. So type in if string.isNull or empty and pass in filePath. If that's the case, simply return so that we do not try to load on an empty path. Before we load our graph, we need to make sure we remove any element that's present in the graph. We do not need to reset the graph file name because the load method will update it already. So call in clear. We can now load our graph, so first call in DSIOUtility.Initialize. In here, we'll have to pass in GraphView as the first argument, and then our file name as our second argument. However, we only have the file path and not the file name. Thankfully for us again, C# has a method in its path class that allows us to get the file name from a path without its extension. So type in path and import its namespace. Then type in .getFileName without extension and pass in file path. This will get us the graph file name with the graph added at the end, which is what we need. When that's done, simply call in DSIOUtility.load. Of course, don't forget to add the button to the toolbar. So in our add toolbar method, type in toolbar.add load button, just under our save button addition. If we save and go back to Unity, we shall now be able to load any graph we have.